This is Module 2 lecture on dimensional analysis. Again, having a copy of the video examples in front of you will help you follow along. Dimensional analysis forms the basis for all of the drug calculations we'll be doing for the rest of the semester. And we're starting with very simple problems so that you can get the concept down. I'll be referring to some terms: answer label, starting factor, and conversion factor that I want you to be familiar with. Starting with question 1, each classroom will hold 30 chairs. How many chairs will fill 7 classrooms? We start our problem with what the question is asking. How many chairs? This is our answer label and also the start of our equation. We're solving for chairs. Chairs equals. And we'll have a numerator and a denominator. It's very important to put chairs in the numerator of what we call our starting factor. And we go back to the problem and we look for something related to chairs, similar to 1 dozen equals 12 eggs, a relationship. In our problem, it says that there are 30 chairs in each classroom. So we fill that relationship right here in our starting factor. "30 chairs per classroom" is our relationship. Then we put a multiplication sign, draw another line, and this is an important point. We take the unit of measure, which is classroom, and we put it in the numerator of our next factor. And we go back to the problem, and it says how many chairs will fill 7 classrooms. So we're looking for 7 classrooms. That means we're done with our problem, and an important step is to put 1 in the denominator of the last factor. And then you cross-cancel what you can. Classroom in this numerator with classroom in this denominator, so that you're left with just chairs, which is in our answer label. Then we do our math calculation, and we know that we multiply across the numerators. "30 times 7 is 210. Multiply across the denominators, which is 1. And we leave it at 210 chairs. It's very important to bring your answer label over to here. It will take 210 chairs to fill 7 classrooms. Let's look at the second problem. Each table at a banquet hall seats 8 people. How many tables will be needed to seat 400 people? We start with the question. How many tables? Again, that forms our answer label. You'll see that before I go back to the problem, I make sure to bring tables from the answer label into the numerator of our starting factor. Go back to the problem. Each table can seat 8 people. That's our relationship. Before I go back to the problem, I'm going to draw a time sign. Put people in the next factor. And I go back to the problem and it's asking about seating 400 people. So I'm done, and I put a 1 in the denominator. Cross cancel people, and that leaves just tables, which is in my answer label. Then I do the math. I divide 400 by 8. It equals 50. I bring down my answer label. You'll need 50 tables to seat those 400 people. Number 3. It takes 3 scoops of powder to make 2 quarts of lemonade. How many scoops will be needed to make 10 quarts of lemonade? The question is, how many scoops? Follow the steps. Go back and look at your problem. What do you know about scoops? 3 scoops will make 2 quarts. How many will we need to make 10 quarts? Plug in your numbers. Last step is to put a 1. And then we cross cancel quarts, being left with only scoops. And we do our math. 3 times 10. 2 times 1. 30 over 2 divided equals 15. Bring your answer label down, 15 scoops. Number 4, you are making jumbo submarine sandwiches and will need 3 tomatoes for every 5 pounds of lunch meat. If 12 pounds of lunch meat are used, how many tomatoes will be needed? The question is, how many tomatoes? What do we know about tomatoes? Well, 3 tomatoes are for every 5 pounds of meat. I use the hashtag for pounds instead of putting LB because the L could be mistaken for a 1. We're using 12 pounds of meat. So we're done. Cross cancel meat. We do our math and get 36 over 5. And when we divide, it equals 7.2. We can round that to 8 tomatoes in order to have enough.